Hey guys, Mr. Gran here, 9.1 polygons in the coordinate plane. In this video, we're going to go through some examples of classifying and doing some work in the coordinate plane with polygons. So starting out, we've got our triangle here. We're using slopes to determine whether or not ABC is a right triangle. So looking at this, I kind of want to know which one do I think is the hypotenuse, which one do I think are the legs, which one do I think is the 90-degree angle. And I think it's this one right here. This appears to be the longest side. So I'm going to go ahead and kind of assume that's the 90-degree angle. Now, to figure this out, we need to look at the slopes. And if the slopes are perpendicular, then we know that that is a right triangle. So if I go from A to B, so for AB, the slope, if I start here, it's 1, 2, 3, 4, 5, so minus 5, and then 1, 2 over. So our slope is negative 5 over 2. Then the next one is BC. And so to get from B to C, remember you want to count up first, up or down first, 1, 2, and then 1, 2, 3, 4, 5. So that has a slope of 2 over 5. These are opposite reciprocals. They're flipped, and one is negative, one is positive. So these are opposite reciprocals. That means that they are perpendicular. So that is a yes. This is a right triangle. All right, now finding the length of the longest side. So in this case, we need our we need the distance formula. And so for our distance formula, we're going from A to C. So we're finding the length of AC. This is going to be my x1, y1 is 1, 6. And this is going to be my x2, y2. So that is going to be the difference in the x's. So 8 minus 1 squared plus the difference in the y's, so 3 minus 6 squared. If we start to simplify that, 8 minus 1 is 7 squared plus 3 minus 6 is negative 3 squared. And from there, I'll move that up here. 7 squared is 49. 3 squared is 9, so that is going to give us the square root of 58, which is 7 point something. It is 7.62 is the length of our hypotenuse. All right, next one, using slope to determine if ABCD is a trapezoid. All right, so looking at this one, it would appear that these two sides are our bases. So if those are parallel, we know this is a trapezoid. So we're going to start with BC. And that, if I count up and over, it's up 3, 2, 3, 4, 5, 6. Yeah, so 3 over 6. And that reduces to 1/2. Now let's look at AD, and for that one to go from A to D, I'm going up 1 and over 2, so that is 1 over 2. Because those slopes are the same, that means that it is indeed a trapezoid. So that is going to be, yes, it is a trapezoid. All right, using the distance formula to determine if this is equilateral, isosceles, or scalene. So what we're going to need to do is use the distance formula 3 times here to determine whether or not to determine what type of triangle this is. So why don't we start with DE? So for that, there's our x1, y1, our x2, y2. And so that is going to be 5 minus 1 squared plus 6 minus 4 squared, which is 4 squared plus 2 squared, which is 16 plus 4, which is 20. And the square root of 20 is 4.47. All right, now let's see, why don't I do df next? Really doesn't matter the order that you do these. So again, we've got x1, y1, we've got x2, y2. And so our distance there, we've got 7 minus 1 squared plus 2 minus 4 squared. And that's going to give us 6 squared plus negative 2 squared, which is 36 plus 4 is 40. And the square root of 40 is 6.32. All right, and then the last one would be EF. So we'll call that x1, y1, and that x2, y2. So for EF, let's see, 7 minus 5 squared plus 2 minus 6 squared. And that's going to give us 2 squared plus negative 4 squared. And that is 4 plus 16 is 20, which is 4.47. So we've got two matching sides. We've got two sides of the same length. That means that this is isosceles. So isosceles. Now, a couple of different ways we could do this also. I could get to this point and say, well, root 20 and root 20 are automatically the same thing. I don't necessarily need to go this far if the question doesn't require it. I could also, instead of using the distance formula, I could count up and over and say this is up 2 over 4 and do 2 squared plus 4 squared. Look, it's the same thing, 4 squared plus 2 squared. So a couple of different ways that this can be done. All right, last one. PQRS, we want to find the slope of the diagonal, find the slope of the other diagonal, and determine whether or not this is a kite, and explain. Okay. So our first diagonal, I'll do that in black, from Q to S is right here. So if these cross at a 90-degree angle, if they are perpendicular to one another, that means that this is a kite. That's our rule for that. So our slope is going 1, 2, 3, 4 down, so minus 4 and over 1, 2, 3, 4. So negative 4 over positive 4, which is equal to negative 1. Our other one, our other diagonal, going from P to R, I'm going up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. So up 5 over 5. So that is 5 over 5, which is equal to 1. Negative 1 and positive 1 are opposite reciprocals, right? If I flip the fraction and make it negative, well, 1 flips to just 1, and then it goes from negative to positive. So these are perpendicular. So this is a yes. And we can say that the slopes of the diagonals are perpendicular.